Hey everybody, BTO Pro here. Today, it's gonna be a quick video about a recent refactor I did of some code, taking two components into a, well, you'll see. It's interesting, just basically using the class-based paradigm to make two components function the same, even though they're stemming from one class that will never be implemented. So it's kind of a weird design pattern that I've never used before, so I figured I'd at least bring it up. It's interesting. All right, I'm in my monorepos. We work in monorepos on our projects, and from the last series of videos, I was working on hacks, and so I was getting into some performance stuff. I'll add this on as like a supplement to the playlist because this wasn't intended to be in it originally, but so I was working on hacks, start tooling, it fires up, and I previously was doing that. I was going in and I opened up this make tab and then I refactored these buttons and refactored some CSS and was messing with lit element in the process. So while I was doing that, I noticed in the code that we've written, there's this fly out, right, that opens there, and one that opens there, and there, and there. And the interesting thing about these two flyouts, as I was starting to apply the code that I refactored, is that they're darn near identical, but they're not. So they use the same type of code to achieve the exact same type of UI pattern, but yet I still wrappered a bunch of stuff on, so that this way this said layout and had these options, and this one said template and had these options. So what the code looked like, because we were focusing on that browser item before, is it looked largely like this. So we had a picker, and the picker imported a bunch of things. It imported a drawer, which is that flyout, imported a button, and then it did some event registration, and then it rendered it. And so it rendered, hey, there's an app drawer, and it has a certain title, and so that way, basically, if you envision that these flyouts check in with hacks at runtime and say like, hey, I'm the make flyout, and I'm the layout flyout, and I'm the templates flyout. So that way hacks knows when an event says, hey, give me the layout flyout, it knows which one to open. Okay, so that's the context of what this is. So I refactored it into one like sort of like element part, like part of an element. I don't. It's hard. I'm having trouble describing what it is actually. So let's look at what this hacks picker is. So it extends hacks element. It pulls in the dependencies it needs. I do them via dynamic import, which is this syntax. That way it doesn't block the render tree. So whenever, if you imagine JavaScript modules start to resolve, they get to this one, it sees that it needs lit element and these classes functions pulled in, but it doesn't block the render tree for these ones. It'll kind of spider out after. It's a unique way of doing it. I do it in some performance obsessed videos. But so we have a callback called setup picker, and setup picker calls its own event it dispatches, and it says, hey, I'm whatever the picker is, fire that custom event. All right. Then it says and append a new element inside of ourself, right? This is a this.append child as opposed to a shadow root append. And so it's an interesting little setup here. So basically something's going to call this and it's going to fire an event saying, hey, we're here. And in the process, it's going to add the element inside of itself, inside the flyout that has those additional things. Then if we look at rendering, we've got our app drawer, title, nothing crazy there. Slot effectively becomes, right, if you think of, this is going to be rendered where slot is because it's light DOM. And so this just says, hey, throw it there. Okay. Then we've got the close button, cancel, and a click event handler off of that. With one property, it's title. Nothing crazy going on here. We've got open and close states so that we can fire that off. And then we've also got a toggle dialog that makes sure we have a global function to ensure that, like, if you open this one and then go to open this one, that it tells all the others. Everybody tells everybody else to close effectively, no matter who's open. So that if it's, this popover, that everyone knows, hey, I'm the one that's supposed to be open now for an off-canvas dialog. All right, but interesting thing, we look at the custom element definition. So this class we can close is HAXPicker. Now, when I want to use HAXPicker though, typically with other examples we've shown, I do a window.customelements.define, HAXPicker.tag for the tag, and then point it to HAXPicker, the class, so that I have the tag. But I'm not actually doing that with this one. So HAXPicker extends lit element, and then when I want to implement HAXPicker, or a type of HAXPicker, this is what my abstracted code turns into, for in this case the blocks picker, or what we call the layout. So that's a blocks area is what the code name is under the hood. So then we have a constructor in there, and we call super, which ensures that the things before it are called. So we get a uniform dynamic import as a result of that, and then whatever setup work lit element is going to do. Then we dynamically import a different element, and this element is specifically that browsing capability, that like the guts of what this element is. Then we have dot picker when we say it's blocks. Now the reason I say dot picker is blocks is because once I call this setup picker, you'll see under setup picker, it's going to leverage that that property that's inside that class, and then it's going to fire a normalized event and then append the element into the DOM. So kind of crazy there. And then it's just going to define a tag. So effectively, we've got this like partial element, right? The element that I've defined here that extends lit element, this class, this would never work by itself. It makes absolutely no sense. It's never calling its render lifecycle. It's never actually being defined as a custom element. So it's just kind of most of the wiring of a custom element. Then I extend it and I can just mix in these little bits. And so now, because I then export HAXPicker and HAXBlocksPicker, I always export my classes that I'm working on in these elements. Now when we go to StacksPicker, which StacksPicker is this one, it's this templates. We call this a stack. Like it's just a bundle of elements that get thrown on at the same time. So now let's look at the code for StacksPicker. So StacksPicker references BlockPicker, but then imports HAXPicker from there. And then StacksPicker turns into this very small amount of code that just exports StacksPicker. So now, because setupPicker is effectively doing all of the legwork to make sure that it has the right content added into itself at runtime, and HAXPicker is just a class extending from lit element, but it's never actually implemented as a custom element on its own, I now have this abstracted form where I've got kind of more of the concept of a flyout. And it has everything except rendering baked into it. So I've only implemented it thus far on the layouts and the templates area, but using the same paradigm, then I could do it with this preferences area too, that if the contents that are thrown in here are their own tag, that makes sure that's set up, and that I just give it a preferences title. And then maybe I need to add an additional property for, whether it's off the left or the right side here. But then that's all I'll have to do. So instead of having what I had previously, which was all of the code associated with, in this case, right now, there's a HAX preferences dialog, and there's the HAX blocks picker and HAX stacks picker and app picker. But these different types of picker scenarios, like, hey, you have to pick from an option, if they're coming through the same UI pattern, I could start to leverage this kind of partial element that I've made. So this is kind of expressing an interesting design capability within web components, right? I had these elements, they each are their own. In fact, this one is still its own. And I could roll that out, make sure I get things visually correct, make sure I get the data model correct, and then later come back and refactor. And I actually kind of recommend this paradigm where you may end up making a couple elements that are almost the same, but I would rather you do that and move forward faster, and then know that if the semantic intention is correct, that you could hollow out the guts of that element to just reference a different element. And so you're seeing kind of the sustainability aspect of this, in which now, to the end user, it's the same experience. However, I'm shipping less code to do the exact same thing. And now when I need to change what this design pattern is, maybe we won't fly it out that way, maybe it'll go out all the way, or maybe it'll just drop down from the top. I'm only doing it in one place, and now I'm leveraging it uniformly across other elements. So that is all for this one, as another kind of in the category of sustainability of web components and development paradigm. So cool thing you can do with class-based element code.